concept review for 6.13a. The first question is a histogram, and it's asking you, based on the histogram, which statement must be true. When we're looking at these questions and it's asking you which statement is true, I would go ahead and underline that, and I would say it is, you're looking for what is true. That's what you're looking for, right? So I'm going to come up here to my histogram and I look at, the title is time at current position, number of employees, and time that they were there for the month. So basically this histogram is talking about how many number of employees were employed for this many months at their current position at their job. So the question says there are 160 employees who work for a company. The histogram summarizes the amount of time each employee has been in his or her current position at the company. We're looking for what is true. So we're going to start, and we're going to start with A. And it says there are 5 employees who have been at their current position for 30 to 35 months. The first thing that I would do is look at what it's asking you as far as employees and months. We know that this months, we're going to be looking down here at the bottom, and the employees are over here on the side. So make sure that when you're reading this question that you're keeping in mind where you're looking at for your information, okay? So then once you look and you can see which one matches the true statement, that will be your correct answer. The next question is reasons for being late to work. This is your histogram. We know that is a histogram because it's not spaced out, it's all together, and their categories or ranges. So it says, what is the difference between the percentage of latecomers who blame traffic congestion and the percentage of latecomers who admitted to oversleeping? It is telling you that you can do this to the nearest whole percent. It's asking you what is the difference. When you hear difference, what does that mean you're going to do? Those are key words. Difference means subtract, right? So the difference is subtraction. So it's asking you what is the difference between the percentage of latecomers, okay, who blame traffic congestion, and the percentage of latecomers who admitted to oversleeping. So that would give you, here's your oversleep right here. And then you're also looking at traffic congestion, which is right here, congested traffic. So you're going to compare these two between the overslept and the congested traffic to see what the difference is in percentage. Remember your whole percent, you will not have a decimal, so you're going to round up. 0.5 is whether you round up or round down. Keep that in mind. All right, so number 3, it's asking you small packages of raisins contain different numbers of raisins in each package. The dot plot here shows the distribution of the number of raisins found in 15 individual packages. What can you conclude from this dot plot? Guys, when it's asking you conclude, that means what is your summary? When you look at this, what do you see? What can you interpret? What do you conclude? What do you see based on this dot plot? Okay, so you're going to come to each of your answer choices and you're going to start at A, and you're going to read this statement, and you're going to see if this statement is true based on what you see on your dot plot. Okay, so that's all you're doing with that one. Number 4, it says the box plot sells data for Angela and Carl. Shows sales data for Angela and Carl. Which conclusion can be correctly made about the interquartile ranges of their data? So is what you're going to do is you're going to look at salesperson Angela, you're going to look at salesperson Carl, and you're going to compare, and you're going to see what conclusion can be correctly, that is capitalized. That means you need to highlight that because it's important. made about the ranges of their data. So you're looking at both of their data, not just one person's, but both. Okay? Number 5 is asking you, the histogram shows the number of minutes that users waited to register for classes on a university's online system. According to the histogram, how many users waited more than an hour but not more than 2 hours? So it's asking you how many users waited more than an hour, right? But not more than 2 hours. So you're going to come up here to your waiting time. It's in minutes. And then you're going to look at your number of users on the side. So your waiting time is in minutes. If it's asking you for an hour, 60 minutes is in an hour, right? So if you know 60 minutes equals 1 hour, then you're going to figure out how many minutes are in 2 hours. Then you're going to come up here and you're going to look at that time frame in minutes. So then you're going to look at your time frame in minutes on your chart between 1 hour waited more than 1 hour, but not more than 2 hours. So you're going to look at that range on your histogram and you're going to get your answer of users. So that means you're going to have to combine or add your answer to get your total number of users. Number 6, a teacher kept track of how much money each of their students raised for the fundraiser. She put the data in the line plot graph. How many students raised $50 or more? So it's asking you $50 or more. So not just more than 50, but 50 also. So you're looking at 50 and greater than 50. So you're going to come up here to your line plot graph and you're going to count the X's that you see that are $50 or more, and that's your answer. Okay. Number 7, the prices in dollars of 50 randomly chosen types of shoes at 4 different stores are shown in the box plots. At which store would a person most likely pay $60 for a pair of shoes? This is capitalized. We know that that's important. Okay. It's asking you $60 for a pair of shoes. So which store would a person most likely pay $60 for a pair of shoes? So you're going to come up here and you're going to see which of these do you see on the box plot where it seems that most of the data, which are the boxes, right? Your data is the boxes. These are your ranges, okay? These are your ranges. Each of these are your ranges. So each of these boxes is what you're looking at. Which of these, A, B, C, or D, do you see that the data is most condensed or most focused on $60? So the number line is your dollars, right? Which one of these do you see that the data is mostly condensed on or closest to $60? That's what you're looking at. All right. Number 8 is according to the histogram, how many shipments had more than 20 light bulbs broken? So you're looking at more than 20, not 20 or more, but more than 20. So you're going to come up here. This is your number of broken light bulbs and your number of shipments. It's asking you how many shipments had more than 20 light bulbs broken. So you're going to come up here to the number of broken light bulbs. You're going to find the numbers that are more than 20. You're going to look at your chart. You're going to take the frequency, right? You're going to take the frequency of each of the ones that are more than 20 light bulbs, and you're going to add them together to get your total number of shipments. Number 9 is Miss Cook made a stem and leaf plot of the grades on her Chapter 5 test. If a 90 or above is an A, how many A's were on the test? So you're looking at 90 or above. That's what you're looking for. So when you're looking at these, it's important to note that your first number is the first number of your actual whole number. So for instance, the 4 and the 9, that would be 49. 5 and then the 6 and the 8 would be 56 and 58. The 6 and the 9 would be 69. 7 and 0 would be 70, 72, 76. Okay, so that's how these the stem and leaf plots work. So keep that in mind when you're looking for a 90 or above. That each of these numbers means that this is an individual number itself. Okay, so that would be like 90, 93, 94, 94, 95. This would be 100 and 101. So keep that in mind whenever you're looking for a 90 or above, that each of these numbers is the beginning of your whole number. Okay. Number 10, Jenny recorded the weight of 5 dogs. Each dog weighed a different amount. She recorded the results on a box plot. Which conclusion can be made about the interquartile range of Jenny's box plot? So what you're going to do is you're going to look at your box plot. You see your pounds is at the bottom, and you're going to read each of these statements, and you're going to see what is true about what you see on the box plot. So remember, your data range is in these boxes. So keep that in mind. Okay.